Today we are going to finish the notes on implicit differentiation. Implicit differentiation, part 2. We're going to start with a bit of review. I hope you enjoyed your day of no calculus yesterday. Did you guys end up watching a movie in the auditorium?
Yeah, we didn't finish it because about 15 minutes.
That's no fun. Okay. Here is the problem I want you to do. Find dy dx for the following. X squared y plus 2x to the fourth minus 3y equals 6. Find dy dx for x squared y plus 2x to the fourth minus 3y equals 6. Okay. For those of you who were not here yesterday, on Tuesday, a little quick review. I'm not going to do the work for you. I'm just going to kind of talk you through it. First of all, those of you who were here, do you see any rules that we have to use in this problem? I see product rule. Which term? The first one. The first term has to have product rule. X squared is the first, y is the second. Okay? When you take the derivative of a y, we don't solve for y first. You take the derivative as if it was an x. You pretend like it's an x. Take its derivative, and then tack a dy dx on the end. Do you remember that from Tuesday? Okay. Go ahead and try to start working this problem at your table. So, x squared dy dx plus y times 2x, 1d2 plus 2d1, plus 8x to the third minus 3 dy dx equals 0. Let me stop and say something right here. Very important that you need to know. Okay, go back to the original problem. How many y's do you see in the original problem? How many dy dx's did we come up with? That will always match. Okay? Now some people accidentally forgot the dy dx on this term right here. So if you know that if there's two y's in the top, you're supposed to have two dy dx's, that's kind of a red flag that you need to go back and double check your work. You follow what I'm saying? The number of x's in the original problem will always match the number of dy dx's in your answer. Okay? So once we get to here, we've got to clean it up a little bit more. So we have x squared dy dx plus 2xy plus 8x to the third minus 3 dy dx equals 0. And it's always the same steps. Take the derivative, move the non-dy dx's over it. X squared dy dx minus 3 dy dx equals negative 2xy minus 8x to the third. Now what do I do? Factor out the dy dx. dy dx times x squared minus 3 equals negative 2xy minus 8x to the third. Are we good? And then divide by the x squared minus 3, x squared minus 3, dy over dx equals negative 2xy minus 8x to the third over x squared minus 3. And we are finished. Okay. Questions? Walked around, helped those who were close, helped those who were kind of really more lost, and I think we're doing good. Now, I have two examples. Here's the first one. Given x squared plus y squared equals 100, find d squared y over dx squared. Now, what did we just talk about the fact that that means?
The second derivative.
Double derivative, second derivative, exactly. Which means we're going to take the derivative and then we're going to take the derivative again. Okay. Bless you. All right. Are we going to have to use product rule on this problem? No. This one's a pretty simple one. So, derivative of x squared
2x
plus derivative of y squared 2y dy dx, because you just took the derivative of a y. equals 0. Yes? Why do I keep the y? Because in your brain, what I want you to do is change y squared to x squared. What was the derivative of x squared? 2x. Derivative of y squared is 2y times dy dx. You see what I'm saying? Because it didn't have a power. The ones up here was just a y. Yeah, you keep the y. Okay. Who could tell me the derivative out loud of y to the third? What's the derivative of y to the third? Raise your hand if you know. Go for it, Kyle. 3y squared dy dx. Y'all see what I'm doing? Who thinks they can do y to the fourth? Aaron, give it a shot.
Or y to the third dy dx.
Very good. Okay, let me jump. How about y to the ninth? Go, Chris. 9y to the eighth dy dx. Are you seeing it? Okay, let me go a different route. Who thinks they can do sine of y? Sine of y. I want somebody new to do it. Somebody new. If you've already answered, you can't raise your hand again. Barrett, you want to give it a shot? Cosine y dy dx. Okay? Would be a good thing. What about tangent of y? Anybody want to give that a shot? Go for it, Brittany. Secant squared y dy dx. Very good. Exactly. You getting the hang of this? You just see it in your brain as an x. Then you take the derivative and then throw a dy dx on the end. Okay. Now, what's the next step in solving for dy dx? Well, not yet. We got to clean up and solve for dy dx. Subtract what?
Subtract
the 2x. So minus 2x minus 2x. Okay. 2y dy dx equals negative 2x. And divide by the 2y. Now, because we're going to have to take the derivative again, we want to clean this up as much as possible at this point. So dy dx equals, how can I clean that? Negative x divided by y. Agreed. That's the first derivative. Okay. Now, the second derivative is just taking the derivative of that. Okay? So if I'm taking the derivative of dy dx, that would just be this, d squared y over dx squared. Okay? So d squared y over dx squared equals. Okay. Do I have to use a rule on this? I have to use the quotient rule. Very good. So I'm going to draw my line. We're going to go very slowly. Okay. Quotient rule starts low, d high. So when I write low, do I write y or do I write dy dx?
Y.
I write y because I'm just copying. Low times d high. What's d high? Negative 1. Minus high. Now high is already negative. Be careful. It's minus a negative x times what is d low? Dy dx over low squared. How do I write low squared? Just y squared. Did y'all follow that? High d low. D low, the derivative of y. The derivative of x is just 1. The derivative of y is just 1 times dy dx. So that's what the dy dx is there for. Okay? So I need to clean this up. D squared y over dx squared equals y times negative 1 is negative y plus, those two become a plus, x dy dx over y squared. Okay. Everybody understand where all this came from? Now, the only thing is, when you're doing a second derivative, you cannot have a dy dx within the problem. So I've got to somehow get rid of this. Does anybody have a suggestion? Aaron thinks he knows. Tell me.
When you divide, and then you flip and multiply on the other side.
Well, how would I get rid of this term? I've got to get rid of the dy dx itself because I've already got this by itself. I'm solving for d squared y over dx squared. Yeah, but I'm still going to have the dy dx in there. How do I get rid of the dy dx? I just erase it. That's a great answer. Just erase it. That sounds like a good idea. Can't do that.
You couldn't split the fraction up and multiply by others.
But that's the dy dx would still be there.
Is it just one?
Whoa. Who just said that? Christina. Look right here. dy dx equals what? Negative x over y. Very good. Very good. Waiting for somebody to see it. There it is right there. There's your key. So I'm going to write this in red. dy over dx equals negative x over y from up here. So that's going to go right there. And those of you who were talking about how to clean it up, yes, we're going to do that after we get rid of this thing. So we have d squared y over dx squared equals negative y plus x times negative x divided by y over y squared. There we go. Now it's all x's and y's. Okay, did everybody see what I just did? Okay. Now, in the past, have always tried to clean up the top and then flip up the bottom. And then I had the epiphany this morning. Split the fractions up. I got only one thing on the bottom. It's going to make life a whole lot easier. So that's what we're going to do. So we can do negative y over y squared, right? Plus, now be careful. How do you combine these two together right here? Negative x squared over y. Because this is x over 1, right? Multiply straight across. So we have negative x squared over y squared. Okay, my final answer is going to be down here. How does this first fraction clean up? Negative 1 divided by y. Do you all agree with that? Okay. On this one, I'm going to do a little math up here before I clean it up. When you have a fraction over something else, you put a 1 under that, under the y squared, and then this little guy flips up there, times 1 over y squared, and this will compose the final term, plus negative x squared, or you could have done just minus, over what? Y cubed. And that is the answer right there. Okay? So, what was the key to this problem? The key to this problem is whenever you're doing a second derivative, you do the derivative, solve for dy dx, then you keep going. You'll always end up with a dy dx in here. So you go back to what you just solved, plug it in, and then clean it up. Okay? Because your final answer can only have x's and y's in it. No dy dx's. Any questions? Okay, one more problem. This one takes a minute to write down. It says, example, find the points on the curve where there are horizontal and vertical tangent lines. Find the points on the curve where there are horizontal and vertical tangent lines. Now, I haven't given you the equation yet. I will in just a second. Now, the equation looks intimidating, but honestly, it's not that hard to work. Here we go. 25x squared plus 16y squared plus 200x minus 160y plus 400 equals 0. Okay, you have worked with equations like that before. That right there is in Algebra 2, you were given problems like this, and you had to tell me, is it a circle, ellipse, hyperbola, or a parabola? You remember problems like that? When they're all multiplied out. How do you know it's an ellipse? You're right.
Because the coefficient of x and y.
The coefficients on x and y are different because 25 stretches it farther this way, 16 than this way, and it's added instead of subtracted. If subtracted, it would be a what? Hyperbola. That's one. Okay. So, but look at the problem. Do you see any product rule or quotient rule or chain rule in there? Not a bit. The derivative of that's not going to be too bad. Okay, I want to skip down about 6 or 7 lines, and I want to write down horizontal tangent line. How do you find where horizontal tangent lines occur? We've done this before. You set the derivative equal to 0. And now, what part, it's going to come out to be a fraction. Every one of these has been a fraction answer. Which part of the fraction gets set equal to 0? The numerator. Okay. Numerator. Okay. Now, I haven't taught this one before. Vertical tangent lines, not vertical asymptotes. Vertical tangent lines, you set the derivative equal to 0 of the denominator. So anytime you're working with tangent lines, it's always the derivative. If it's horizontal, you set the top equal to 0. If it's vertical, you set the bottom equal to 0. Haven't we set the bottom equal to 0 in the past? Or vertical asymptotes? Yes, but that's always been the bottom of the original equation. Okay, so let's go back up here and work this out. And the reason I wrote that down is if I get caught by the bell, we can go back. You can go back and look at the last part of the video, and you'll know what to do. Okay, derivative of 25x squared. 50x, that was easy. Plus derivative of 16y squared. 32y dy dx. Matt's always remembering, thank you. Plus the derivative of 200x, just 200, minus 160 dy dx. What about the 400? 0 equals 0. Okay, not too bad. What's the next step? Subtract the 50x and the 200 because both of them do not have dy dx's. So 32 dy dx, whoops, made a mistake, that's okay, minus 32y, that's what I was doing, minus 160 dy dx equals negative 50x minus 200. What's the next step? Factor out dy dx. Dy dx parentheses 32y minus 160 equals negative 50x minus 200, and divide by the parentheses. So dy dx equals negative 50x minus 200 over 32y minus 160. There's the derivative.
Do you ever factor out the derivative?
If it's a quadratic, yes, I would do that. But
For that, just like
not for that, because I'm just going to set it equal to 0, and I'd have to remultiply if I did. Okay? So now, let's do the horizontal tangent lines. So we set the derivative's numerator equal to 0. So we'll have negative 50x minus 200 equals 0. Negative 50x equals 200. So x equals negative 4. I'm not going to make you go find y. It's too much work. Okay? Is that easy enough? So now the denominator, 32y minus 160 equals 0. 32y equals 160, and I'll tell you right now that that happens to go in 5 times. So y equals 5 is where the vertical tangent lines will occur. All right? Any questions? I am done.